Hello everybody! In this video I would like to explain you the web server of the master a little bit more in detail. As I already mentioned in the video before, you get to the web server of the master by typing in the IP address of the master into the address bar of your browser. If this doesn't work, please check again whether you are in the same network as the master and that you have the same IP address or the same IP address in the same subnet. If that worked, you will see this homepage, which runs directly on the master, and that represents also an overview of the device itself. So within this overview, you can find the code and the name of the device. Also important, the firmware version of the device itself. And of course, you can also see the IP address that is set, the subnet mask, and so on. Additionally, on the right side, you can see an overview of the master itself and its current status, like you would directly look on the master. And this is an one-to-one copy, so this means that when light is flashing here, it is also flashing on the real device. And if you are wondering what the red blinking LED means, you can open the LED key over here, and you can see that this is the LED which is marking BF, so which means we don't have a data exchange. And that makes sense because we don't have a Profinet controller connected, so we don't have a bus connected. So that's fine. We don't have a communication with a PLC. And also you can see here the individual ports of the master. In this case, we have a port master and additionally the connected devices if they are IO-Link devices. So you see here in port 1 there is an IO-Link device connected. And clicking on the port, you can get to the detailed overview of this individual port. On the right, you have an overview of the master, which allows you to click through the different ports. And as you can see, I have no data here because there are no devices connected. On port number 0, I have a connected device, and here I see the data about this device. And as you can see here, I connected a Balov device, and it's a BMP. It's a magnetic field, magnetic position measuring system, and this is mounted here on a small cylinder, which I can extend and retract, and it's measuring the position of the piston. Additionally, I can see the process data coming from the device, so by changing the piston position, I can see how the value is going to change. So furthermore, I can read and write parameters from the device. So as an example, I can set parameters via the like the switching points, or I can read the name of the device or the ID of the device or stuff like this. I will demonstrate it here in the index field. I can enter a parameter index. So parameter 13, for example, is the product ID, shown by this field over here. And subindex is usually 0, and by pressing apply, I get an information right here. And this is formatted in ASCII, but as you can see here, for example, 30, 30, 30, this is 3 times the 0, and so we can conclude that this is actually the right index, the right ID. By using the IODD function, I can upload IODDs to the device. And IODDs are device description files for IO-Link devices. It's like a driver file which is described in XML and shows how the device is built up, how the data of the device is built up, how the process data is looking like, what parameters there are, and stuff like this. So to upload this, I need to log into the device using the standard password in delivery state. So it is BNIPNT in capital letters. And I can log in and I find the page for the IODD management. And as you can see here, there are no currently uploaded IODDs. I'm going to upload one. And I need to find it, so easiest way would be go to the product finder of the manufacturer. So in this case, for example, Balov. And here by using the search function, I can find the appropriate device and I can download here the description file in the download area. So that's one possibility. of doing it. The other one would be using the IODD finder of the IO-Link consortia. And here you can find, or at least should find, all IODDs of all manufacturers. And I can also search here for the product ID and can download the IODD directly here as well. So I have downloaded and unzipped the IODD. And here you can see the files that are included in this package. So this is not only the IODD that we have as an XML file, but also inherent product pictures. So in this case, we have more than one length. There are more than one pictures in here. What I can do now is to upload the IODD. So that it is properly stored, I have to rename it. Here I can see how the IODD should be named. I'm just going to copy this, rename the XML file, and do the same also with the picture so that it looks perfect at the end. And then over choose file, I can open the corresponding IODD, and you can see that's the XML file here. So now I have selected and uploaded it. And now I can select and upload the corresponding picture as well. And the picture is now marked with an X. So the sign, that means that it is uploaded correctly. And the exciting thing about what I can do with this IODD, or why I have uploaded it, we can jump back to the port set that I can show you. So for the same sensor, I can find the data now much more detailed and visible. So the pictures in there, I can see the process data, but not like raw data. Now I can also directly read the individual bits and bytes for each parameter. I can just read them fine and normal, like switching points, measurement value, and stuff like this. If I scroll down, I find also more parameters listed and in detail. And I'm able to read them directly. So for example, I can read out here the switching points and at which position the switching points are set. And when I'm logged into the master, I'm also able to write a new switching point directly to the device or other parameters. And if I read it again, then the value is now accordingly set on the sensor. So I do not need to turn a small screw on the device. It's all done via the web server, and that's way easier to use. With the config tab, I can set the status of each port via the web server. So this means I can set the ports to IO-Link or to another mode like digital input or something like this. To do so, I can select what I want from a drop-down menu here. And after having selected what I want, I can click on Set Ports. And now you can see here on the LEDs, all 8 ports are now switched to IO-Link. On 7 ports, there is no IO-Link device connected, so the blinking LED is showing it. And if one is connected, you see it's glowing all the time. It's important that you have to be logged in for setting the ports. So it's the same step as for the IODDs. You have to do it here. With the log tab, you can see the log book or log of the master. And here you see the history about events that occurred at the master. For example, a connected device was disconnected or a new device was plugged in, stuff like this. The IP address has been changed, for example, parameters have been read incorrectly, warnings, errors, informations, and stuff like this is going to be logged here. And you can see it here. You can also set the module time here over set module time. This will transfer the actual browser time to the BNI master. So now I just will simply disconnect the connected device and reconnect it to another port. Then I can update the log via update log. And now you see that port 0 appears down here, device disconnected, and port 2, the same device connected. So that's it for this video about the web server. And in the next video, I will explain what kind of web service this web server is going to provide as an interface, and how we can use this interface in future projects. So thanks for listening and enjoy trying out.